Hi everyone. We have discussed the basic examples on matrix spaces, especially we have discussed about the discrete matrix space as well as the usual matrix space. Also, we have discussed about an important example, that is how can we induce the matrix from a given matrix. That means if we have any kind of a matrix space, then we can have more than one matrix on it. The example was dx comma y is equal to d star x comma y is equal to dx comma y over 1 plus dx comma y. Now in this example, if I'm supposed to choose the new space, let us suppose I have a space c a comma b, which is a space of real valued continuous functions, and the functions are defined on a comma b. Now whatever the function I'm going to take from this space, say I'm taking two functions f and g at least, which belongs to this c a comma b. I'm defining a function. You know that it's a metric function. Later on I will prove that it is a metric, but just for the sake of simplicity, let us call this as a function. So the function df comma g I have defined as supremum over u, the absolute difference between these two functions, mod of f of u minus g of u. Then we shall show that c a comma b, like this space c a comma b, with respect to the function d, that is a matrix space. So we know that in order to prove it a matrix space, we first of all have to show that this function is a matrix. So there are the four conditions that we have to satisfy. The very first condition is what we have to show, that df comma g is greater or equal to 0. So I just want to use here a board to prove this example. Now let me prove this example. The very first thing that I have to show, that is df comma g is greater or equal to 0 for all f g in c a comma b. Now it is true, this thing is true. Why it is true? Because by definition we know df comma g is equal to supremum over u modulus difference of f of u minus g of u. And since the modulus difference, mod is always greater or equal to 0, so this is greater or equal to 0. Even it is having a supremum also, so it is greater or equal to 0. Means what we have, df comma g is greater or equal to 0, and this is true for all fg in c a comma b. Now the second condition that I'm going to prove is df comma g is equal to 0 if and only if f is equal to g. Let's try to put f equal to g and see whether we get df comma g equal to 0 or not. So we put f equal to g. In other words, by means of f is equal to g, what I actually mean is that f of u is equal to f of, g of u for all u belonging to a comma b. Now from this statement I can say mod of f of u minus g of u is equal to 0 for all u belonging to a comma b. And since this is equal to 0 for all u belonging to a comma b, means the supremum of this quantity, supremum over u, mod f of u minus g of u, is actually equal to 0. And this is the definition of df comma g, means df comma g is actually equal to 0. So I supposed f is equal to g and I got df comma g is equal to 0. Now what I suppose? Now I will suppose that df comma g is equal to 0. So now I put df comma g equal to 0, and we have to check that whether we get f equal to g or not. So when I am saying that df comma g is equal to 0, by definition of df comma g, it means the supremum over u a comma b, it is belongs to here. Mod of f of u minus g of u is equal to 0. Now the supremum of this quantity is equal to 0. Supremum of this quantity is equal to 0. It means the quantity here is equal to 0, means modulus of f of u minus g of u is equal to 0, and mod of this thing is equal to 0 means the quantity inside the mod is equal to 0 actually. G of u is equal to 0, and this is only possible if f of u is equal to g of u. So what I got, I supposed this is equal to 0, I got this, means it satisfies this condition. Now let's try to prove also the rest two conditions. What's the third condition that I have to prove? The symmetry. So I will take d f comma g, and I know the definition of df comma g, and that is equal to the supremum over u a comma b mod f of u minus g of u. And can I write it also equal to supremum of u belonging to a comma b mod of g of u minus f of u. So I can shift these two because they are in mod. Modulus में है तो हम shift कर सकते हैं easily इनको. And this will be the definition of d g comma f. This is f here. So it proves the symmetry. So what we got, d f comma g is equal to d g comma f. Now what is the last thing that we have to prove? Now I will take three functions because I'm going to prove the triangle inequality. So I will take f, g and h belonging to c, a comma b. Let me take mod of f of u minus h of u. Okay, what I will do, I will write it equal to f of u plus g of u minus g of u minus h of u. Easily I can write this because I can cancel out this and this, and again I will get the same thing, that is from the left hand side. And now I'm going to use here the inequality, so I can write it less or equal to mod f of u minus g of u plus mod g of u minus h of u. नाउ देखिए यहां पर हमारे पास ये स्टेटमेंट है, ये स्टेटमेंट खुद लेस और इक्वल टू होगी द सुप्रीमम ऑफ u belonging to a comma b mod of f of u minus g of u plus supremum of u belonging to a comma b mod of g of u minus h of u. Why? Because these two statements are obviously less or equal to than their supremums. So supremum is always greater or equal to than these two. That's why these two are less or equal to the supremum of these two. Okay, and this one is the definition of d f comma g, and this one is the definition of d g comma h. Okay, so d f comma g and d g comma f. Similarly, this thing, this quantity, if I'm going to use here supremum over a comma b, so similarly this quantity is less or equal to its supremum, means if I will use supremum here also, so I will get the definition of d f comma h, which is less or equal to d f comma g plus d g comma h. रिमेंबर यहाँ पर लेस और इक्वल टू क्यों आया, क्योंकि ये लेस और इक्वल टू में ही चलता आ रहा था. So df comma g df comma h is less or equal to this thing, so which proves the triangle inequality. फर्दर अगर आपको यहाँ पर कहीं पर कंफ्यूजन लगता है आप कमेंट कर सकते हो. अदरवाइज अगर आपको ये समझ आ गया वो सारा तो आप लाइक कर सकते हो मेरे वीडियो को. एंड लास्ट में क्योंकि मैंने ये प्रूव किया कि ये मैट्रिक बनाती है, सो मीन्स जो सी ए कॉमा बी with respect to the metric D, it forms a metric space. Thank you.